Have you ever been scrolling through an app and felt like it's, well, reading your mind? How does it just know what video you want to see next or what song you're in the mood for? It honestly feels like magic, right? But it's not. Behind the scenes, there's some seriously cool technology at play. And today, we're going to pull back that curtain and show you the secret ingredient, something called a knowledge graph. Okay, so let's make this real. Picture this. You're on YouTube. You watch the movie Inception. Then, a little later, YouTube suggests Interstellar. Now, how on earth did it make that jump? It didn't just see one movie and call it a day. No, it understood the connections between them. And that, right there, is the core problem that every recommendation system is trying to solve. I mean, let's be honest, we are all drowning in a sea of content. There are millions of videos, songs, and things to buy, and it can feel totally overwhelming. Recommender systems are supposed to be our life rafts. They're designed to slice through all that noise and take us from feeling paralyzed by choice to feeling like, wow, this thing really gets me. And you know what? They are shockingly good at it. Get this, some research suggests that AI recommendations are behind more than 75% of what people actually end up watching on YouTube. That is a massive amount of influence, and it's shaping our digital world every single day. So, how did they get so smart? Well, the old systems were pretty simple. You clicked on something, and it just saw that one click as a single isolated event. But today's systems, they're playing a whole different ballgame. They don't see separate choices. They see this rich, interconnected web of context where everything is linked to everything else. So, how do these systems actually connect all those dots? Well, the piece of tech that powers this whole web of context is the knowledge graph. And trust me, it is an absolute game changer. The easiest way to think of a knowledge graph is like a giant, super intelligent mind map. It doesn't just store individual facts about things, it stores the relationships between them. It's connecting movies, people, music genres, you name it, all their different features into one enormous, living network of information. And this visual really nails it. Let's go back to our movie example. The system doesn't just see, okay, a user named Jack watched Inception. No. The graph knows that Inception is a sci-fi movie, and it was directed by Christopher Nolan, who also directed Interstellar, which is also a sci-fi movie. All of a sudden, that one single click has opened up a whole universe of potential interests. And this is the fundamental breakthrough. With a knowledge graph, nothing is an island anymore. Every single item, whether it's a movie or a song or a product, exists inside this rich web of relationships. And that's the real secret to making smart recommendations. Okay, so having this amazing map is one thing, but you need an engine to actually navigate it, right? For knowledge graphs, that engine is a really powerful type of AI called a graph neural network, or GNN for short. This is the part that does the heavy lifting and actually learns from all those connections. And this diagram just lays out the whole process perfectly. You start on the left with that big, messy, complex knowledge graph. Then the GNN gets to work, does its magic in the middle, and what comes out on the other side? That clean, simple, ranked list of recommendations that you see on your phone. All right, let's break that down just a little bit more. So you start with a raw graph. Then comes the magic step, graph embedding. This is where the GNN creates a really sophisticated profile for you and for every single item. You can think of this profile, it's called an embedding, as a kind of digital fingerprint. Then, the system just calculates a match score between your fingerprint and all the other item fingerprints. And voila! The result is your very own personalized top 10 list. So you might be wondering, how does this GNN engine actually learn? How does it get so smart just by looking at this map? Well, let's pop the hood for a second. It's actually a surprisingly simple two-step dance. The source material we're using for this explainer puts it perfectly. A GNN really just does two things, over and over and over again. It uses an aggregator and an updater. That's it. Think of it like this. For any given movie in the graph, say Inception again, the aggregator's job is to look at all its direct neighbors. It gathers clues from the director, the actors, the genre, even other people who liked it. It sucks in all that neighborhood gossip. Then, the updater takes all those clues and uses them to refine and, well, update the profile for Inception, making it way smarter and more aware of where it fits in the world. Now, I know this looks a little complicated, but don't worry. This is just a more detailed picture of that exact same process. On the left, you see the aggregator pulling in info from all the neighbors. And on the right, you see the updater combining all that neighborhood gossip with the movie's own info. The key is that by repeating this simple two-step process millions of times across the entire network, the AI starts to build this incredibly deep, nuanced understanding of how everything is connected. Now, this isn't just a cool science project. This whole technology is designed to solve some of the biggest, most practical headaches that recommendation systems have been dealing with for years. You've probably felt this one yourself. It's called the cold start problem. It's when you sign up for a new service and it knows absolutely nothing about you. So what can it recommend? It's like walking into a store where the shopkeeper has never seen you before and has no idea what to show you. And this is where the knowledge graph is a total superhero. Because even if the system knows zip about you, the second you click on just one thing, say a new song, the graph instantly has clues. It knows the song's genre, its record label, other artists that are similar. It can immediately make a really educated guess based on that one item's neighborhood in the graph. And it's not just about solving that cold start problem. This approach also helps these huge platforms to scale. I mean, they can't possibly analyze billions of connections all at once. So the GNN learns to just sample the most important parts, which keeps everything running fast. And for you, personally, it allows for hyper-personalization because it can basically create a unique version of the graph that's weighted towards your specific tastes. So my recommendations will look totally different from yours. So what we're seeing is that these systems are getting insanely powerful and scary accurate at predicting what we'll like. But as they get woven deeper and deeper into our lives, a whole new set of questions is starting to pop up. Questions that go way beyond just getting the prediction right. As this AI gets better and better at guiding our choices, the whole game is changing. The next big challenge isn't just about making the recommendations more accurate. It's about something much deeper. It's about fairness. It's about trust. How do we make sure these incredibly powerful engines are transparent? How do we build systems that we can actually genuinely trust? That's the real frontier, and that's the question that will define the next generation of this technology.